All right, so we are continuing to take a look at some of the questions you guys had on lesson 5.5, this idea of finding all the roots of a polynomial equation using the rational root theorem. So here we've got a quartic, a fourth degree polynomial. And again, the directions are the same. It says find all the rational roots. So I know we didn't look at a quartic in our class today, but hopefully we can kind of apply what we learned to see what we can do with this. So the process is still the same. I got to find P's and Q's. So P is 4, or all the factors of 4. So that's positive and negative 1, positive negative 2, and positive negative 4. Q are all my factors of the leading coefficient, which in this case is 3. So it's positive negative 1 and positive negative 3. All right. So I want to find all the different combinations of P over Q. All right. So I start looking at those. It could be 1 over 1, or it could be 1 over 3, 1/3. Could be 2 over 1, or it could be 2 over 3, 2/3. And finally, it could be 4 over 1, or 4 over 3. All right. So I know here's my list of possible candidates. Now, again, could be as many as 4 of these. All right. But here are my possibilities. So to do this, or to narrow it down even more, I want to look at the graph. All right. So I've got it typed in there. Make sure I've got it right. 3x to the 4th minus 5x cubed minus 20x squared plus 6x plus 4. All right, good. And again, I always zoom 6 it. All right, just to make sure. Okay, and shortly should be graphing this thing. All right, so yeah, quartics typically have this. It looks almost like a W. All right, or if it's flipped upside down, it could be an M here. All right, but I want to look at again all these places here where it crosses. Where it crosses the x-axis. All right. So the tick marks are a little bit hard to see, but again, I know here are my possibilities. All right. So as I start looking at this, let me get a little closer look at it. Okay. Let me do this. All right. Okay. So if I'm looking, let's say at this one right here. So here's my, there's my axis. So this is like -1, negative, maybe that's around -2. Is -2 on our list? It is. So let's try -2. All right. So I'm gonna second trace, find the value at -2. Yep, -2 is a 0. All right, I love it. Okay, good. So we have found one of them. All right, one of them is at -2. Now, here's the thing with a quartic. Okay, we could do synthetic division right now, but that's still only going to get it down to a cubic. All right, so I've got to find one more here. All right, before I get it down to that quadratic, because I know if I get it down to an x squared, then I can use the quadratic formula to find the rest of them. Okay, so -2 is one of them. So we've got that taken care of. This one here, I'm gonna see if I can see what that one is. It's a little bit less than 0. Okay, I'm gonna try -1/3. All right, let's just see if this works. So second trace and find the value at -1/3. Oh, look at that! You guys realize how lucky you are to have me as a teacher. I'm just that good. All right. So -1/3. Now, again, I could go through and start checking. But again, I want to get this down. Let me see if I can get it down to a quadratic, and then we don't need to guess and check anymore. All right. So I'm gonna do synthetic division, but I'm gonna have to do it twice, once with each of these. All right. So again, synthetic division is 3, -5, -20, 6, and 4. And the first one I'm going to do is -2. You could do these in any order you want. It really shouldn't make a difference, but I'm going to do it with the first one I saw. And again, it's all add and multiply, right? So add, multiply, add, and multiply, add, and multiply, add, and multiply and add. Beautiful. Okay. And again, here was the problem I'm talking about. Why we had to do it twice. So this was 3x to the fourth. That means this is still 3x cubed. This only drops by 1. And that, I still can't solve a cubic. So I got to do this again. And I'm going to do it with negative 1/3 with my second rational root that I found. So now I add and then multiply. And again, multiplying by negative 1/3 is like dividing by negative 3. So 3 divided by negative 3 is negative 1. Add, and then divided by negative 3 is positive 4. Add 6 times negative 1/3, I think, is negative 2. And again, we end up with 0 here. Okay, we should finish out with some zeros here. Okay. All right, so what I get is 3. Now it's an x squared because it started with a fourth degree, then a third degree, so now it's at a second degree. 3x squared minus 12x plus 6 equals 0. You can start plugging this in the quadratic formula. Before I do that, I recognize, hey, wait a minute, these are all divisible by 3. Let me divide that whole thing by 3. So I get x squared minus 4x plus 2 equals 0. But now, all right, Kayla, I know you like the quadratic formula. I like to see if I can factor it, especially if that's a 1, because it's real easy to see if I can factor it. Are there factors of 2 that add up to negative 4? No, there's not, because really the only factors of 2 are 2 and 1, right? And those don't add up to negative 4. So that means this is not factorable. This means the other roots, while we can see them, all right, so they're real. They're not imaginary. They must be irrational. So the only two rational roots for this are negative 2 and negative 1/3. All right. All right. So good example. Thank you. Thank you for asking about this one. This is a good example of maybe having to do it a couple times, but the process is still the same. All right. Find your P's and Q's, graph that bad boy, and look and see what you can estimate, knowing that your answer is right here somewhere. And then just do it as many times as it takes to get it down to a quadratic, because a quadratic we can handle. All right. Hopefully this helps. Again, this was number 14 on 5-5. The answers were negative 2 and negative 1/3. So, all right. Let me know if you guys have any other questions. Take care.